Friends, hi. So today I am going to discuss a final year question paper for thermodynamics. The subject is thermofluids, right? So this is from 2014 final exam. So that means the academic year is 2013-14. And question number 2, part C, only the calculation based problem that is based under the diesel cycle, right? The question I have mentioned under the video, right? But doesn't matter, I will read the problem again. Okay, so the problem is, in an air standard diesel cycle, initially air is taken at a temperature of 27 degrees Celsius and a pressure of 0.1 megapascal. That means at the inlet conditions the pressure is 0.1 megapascals and the volumetric compression ratio of the cycle is 18, and heat added per cycle is 2000 kilojoules per kilogram, and you have to find the followings. What do you have to find? You have to find temperature and pressure values at all the points. Temperature and pressure values at all the points, and the cycle efficiency. Number 2, cycle efficiency. Okay, so now let's see how to do the problem. So now I am going to solve this problem technically. That means now if your exam is closer, now it is not the time to study theory and just memorize the things, because you are writing a thermodynamics paper, right? So you cannot pass thermodynamics by memorizing and loading the things into your mind. You have to solve this very logically. Now carefully see. So now this is air standard diesel cycle, right? So now that means if you want to solve this problem, you must know what is diesel cycle. I will teach that very quickly, right? First we will sketch the PV diagram. So this is P and this is V. What is the first process that we have? We have reversible adiabatic compression. Process 1 to 2, right? Right. I will write that later. Process 1 to 2. The first process is point 1 to 2, which is reversible adiabatic compression. That means you are going to compress the volume, right? Here the volume is let's say V1, and here the volume is let's say V2. That means you are going to compress the volume, right? But be very careful, this is reversible adiabatic compression. Let's write here reversible adiabatic compression. That means in other words we say this isentropic. Isentropic. That means in this kind of processes you are just going to do the compression, but you are not going to add any sort of heat. No heat transfer, right? In the process 1 to 2. That means delta Q equals 0, right? Now after that what we have? So after this process we have heat addition, but at the constant pressure. Here the pressure is, let's say, that is P2, right? So you are going to add some heat to this cycle at the constant pressure. From point 2 to 3 you are going to add some heat, right? Right, some heat. I will sketch that in red color. Right, okay. And then from process 3 to 4, 3 to 4 we have reversible adiabatic expansion. That means it is going to expand the volume, right? But here also be very careful. Reversible adiabatic means there is no any heat transfer, right? It is going to expand the volume. That means the volume enlarges again, the volume is increased, expansion, the opposite of compression. 3 to 4 we have reversible adiabatic expansion, right? That is okay. We can write it also here. Okay, I will write it. And then from point 4 to 1, what do you have? From point 4 to 1, you have constant volume heat rejection. What is that? Constant volume heat rejection. Right. So now we can write the processes again. Right. Let's see. Now what is 1 to 2? Isentropic compression and point 2 to 3 constant pressure heat addition, constant pressure heat addition, right? And point 3 to 4. 3 to 4 we have isentropic expansion, same process type, isentropic expansion, and the last step, point 4 to 1, constant volume heat rejection, constant volume heat rejection, right? So now basically that is the process cycle. Okay, right. So because like before solving the problem you need to have some idea about how this diesel cycle works, right? So now at this time onwards, don't waste your time to understand what is adiabatic and what is isentropic. Isentropic is isentropic is reversible adiabatic, right? The definitions I will mention under the video, right? So now this is the cycle you need to solve the problem. Now we will quickly go into the calculation. The calculation time. Okay, first of all let's sketch the cycle, because it is very easy to solve the problem after sketching the cycle. Now you know what is the definition of the cycle. Better put arrows, 1 to 2 first, then 2 to 3, then 3 to 4, then 4 to 1. Right? Okay. So now let's focus what are the data they have given. Air is taken at a temperature of 27, pressure 0.1 megapascal. Okay, that means inlet conditions. Let's say the conditions for the for the point 1, right? Let's say temperature is T1, pressure is P1. What is T1? Like at the starting point 27 degrees Celsius, but better to keep in kelvins, right? How to write that in kelvins? 273 plus 27, that means 300 kelvins. T1. What is pressure? Pressure is 0.1 megapascal. 0.1 megapascal means 0.1 into 10 to the power 6 pascals. So that is the inlet condition. And in the first part they ask temperatures and pressures at the end of each process of the cycle. That means you have to find the pressure values and temperature values at each and every point. So for that we can make a table, right? So what is the table you can make? You can make a table for the temperature, right? You can make a table like this. Let's say value and the particular value in units, let's say kelvins. You have to find T2, you have to find T3, the temperature at there, T3, and you have to find the temperature at here, T4, in kelvins, right? And like that, for the pressure also you can make a table like that. Let's say value or label, right? And the pressure value in pascals, not megapascals, pascals, right? But if you are going to consider that in pascals, then to each and every pressure value this 10 to the power 6 term will come. Okay, so we will carefully convert the units and try to keep that in megapascals. Okay, right. So what are the pressure values you need to find? You need to find the pressure at here. If you know the pressure at here, there is no any magic. You can easily find the pressure at there also, because that is a constant pressure process. 2 to 3 is constant pressure. That means P2 equals P3. No problem, right? So P2 equals P3. You can find that directly, because if you know P2, you can find P3 and P4. Those are the only pressure values that you need to find, right? So let's see how to do that. And now, in order to save the space, once if I finish calculation for one particular part, I will erase that, because I need to adjust the space, right? I will do the simplification in this space. Right. Okay. Now, in this problem, they have given us what is the compression ratio. That is the ratio of the initial volume to the final volume. That means you have a volume like this, and you are going to compress that up to here, right? You have a volume like that, which is V1, and you are going to compress that V2. So V1 divided by V2 is the compression ratio. So what is that compression ratio that they have given us in the problem? 80. Yeah. Volumetric compression ratio for the cycle is 80. Okay. So that is V1 divided by V2 is 18. So you can keep it as a data. Now, process 1 to 2. Process 1 to 2 is a reversible adiabatic process. Reversible adiabatic process, that means isentropic. Same terms. So there is an equation that we can use in order to find that. If you have no any equation, then how you are going to find, right? So there must be an equation for that. What is the equation for adiabatic compression? That is very easy. P2 divided by T1 equals P2 divided by P1 to the power gamma minus 1 over gamma. You know, gamma is the ratio of Cp divided by Cv. What is Cp? Specific heat capacity at constant pressure. What is Cv? Specific heat capacity at the constant volume. Right? Okay. In the question paper, they have given all the data. So let's write it. What is Cp? 1.005 kilojoules per kilograms per Kelvin. Kilojoules per kilograms per Kelvin. What is Cv? 0.718. 0.718. Is it correct? Kilojoules per kilograms per Kelvin. Yeah. And also they have given us the value of gamma also in the question paper itself. What is that? 1.4. Okay. So now gamma has no units, okay, because that is the ratio of Cp and Cv, so it has no units. No units, okay. So now let's look at the problem. We need to find the pressure at here, we need to find the temperature at here. that means we need to find T2. We need to find P2. Can we use this equation? Of course, definitely this equation is correct, but can you use this equation at the moment? No. So that is why we have to focus the problem. In the question they have given us V1 divided by V2. Compression ratio is given. That means we have to obtain the equation for the adiabatic compression by using the relationship with the volume. Understand? Right. That means there is another relationship for the adiabatic processes. What is that? That is P1 V1 to the power gamma equals P2 V2 to the power gamma. Shall I write it again? P1 multiplied by V1 to the power gamma. That means the power gamma belongs only to this V1 and equals P2 multiplied by V2 to the power gamma. Right? This is also a relationship that you can use for adiabatic processes, and this is also a relationship that you can use for adiabatic processes. But unfortunately, if you use this equation, you will never be able to solve the problem. Got it? Because we need to find pressure and temperature at here. So now if you use this equation, I am very much sure that you can find the pressure without any doubt. So I hope you got it. So now guys, I will erase this part. Okay. Now what is the equation I am going to use, guys? P1 V1 to the power gamma equals P2 V2 to the power gamma. From this equation I can find P2. So let's subject P2. What is P2? P1 times P2 equals P1 times V1 divided by V2 to the power gamma. Am I correct? P2 equals P1 times V1 divided by V2 to the power gamma. What is V1 divided by V2? That is the compression ratio, no problem. What is P1? The original. This is this is multiplication type equation, right? This multiplied by this equals this multiplied by that. So you will not need to do the unit conversion. This is multiplication time, so you do not need to do the unit conversion, right? So this part and this part you can consider whatever the unit that you have, and that is no problem. So what is P1? You know what is P1? That is given as 0.1 megapascals, isn't it? Yep, 0.1 megapascal. Temperature, you know. Temperature, of course, you don't need. V1 divided by V2. Compression ratio. The ratio of the initial volume to the final volume. Right? Okay. What is pressure? 0.1. Multiplied by compression ratio is 18 to the power gamma. What is gamma? 1.4. So let's quickly solve this. What is the answer? 18 to the power 1.4. 5.72. 5.72. megapascals. Right? Is that the same value you are getting? Check it, guys. Simple calculation. Okay. So the same pressure would be applied there because it is a constant pressure process. So no problem. 5.72 units in megapascal. Multiplication type. So 5.72. right? Okay, right. So now I will erase that part. Okay, so if you want to see that part again, you can pause the video and so that, or you can go back, right? This is not difficult, it's very easy. And what is the next thing? You need to find the temperature at there. Okay. So now how to find the temperature? To find the temperature, we need to use another equation. We can either use this equation, which is P2 divided by P1 to the power gamma minus 1 or gamma equals T2 divided by T1. You can either use this equation, okay, because now you know what is P2, P1 you already know, T1 you know, so no problem, you can find T2, right? But let's just say that you directly want to find the temperature T1 without finding P2, because now the reason is, if you want to evaluate what is T2 from this equation, what is this equation? I told you there is another equation for the adiabatic processes, which is T2 divided by T1 equals P2 divided by P1 to the power gamma minus 1 over gamma, okay? But if you are going to use this equation, you need to find P2 first, right? So that is time consuming. So let's try to find kind of an equation where we can directly relate volume and temperature, because you know the volume ratio, you know, that means you know V1, you know V2, initial temperature condition T1 also you know, that means 3 variables are known, the only unknown variable is T2. Let's check whether you can find something like that, right? All these things we have to keep in mind, right? Right. Let's see that. Right. There is an equation called, for adiabatic processes, there is an equation called T2 divided by T1 equals, what is that? V1 divided by V2. That means interchanging the, you know, this suffix term, right, to the power gamma minus 1, right? There is an equation like that. In case if you can remember this equation at the examination, so that means you are lucky. But to be honest guys, let me tell you one thing, to be honest, really I don't remember this equation. When I am writing an examination, I do not remember this equation, right? I remember only 2 equations, that is T2 divided by T1 equals P2 divided by P1 to the power gamma minus 1 over gamma, and P1 V1 to the power gamma equals P2 V2 to the power gamma. So that is the equation that I can remember. So in that case, if I want to obtain this equation, that means I have to do the substitution and find that, right? But doesn't matter, I will teach you that also. Then how to find that, guys? It's easy, it's nothing, because you know this equation. Then just subject P2 and P1, put P1 to this side, P2 divided by P1, then V1 to the power gamma divided by V2 to the power gamma, V1 to the power gamma divided by V2 to the power gamma. That means this gamma power is common, so you can put V1 divided by V2 whole cube to the power gamma, no problem, right? So now what you can do, you know this equation, T2 divided by T1 equals P2 divided by P1 to the power gamma minus 1 over gamma, and this P2 by P1 that you can subject from there, okay? Right. V1 divided by V2 to the power gamma. It's not a magical thing. That means this whole term to the power that. That means you can multiply the powers. Gamma multiplied by gamma minus 1 over gamma. Gamma is getting to cancel themselves. Right? So then what is the remaining term? V1 divided by V2 to the power gamma minus 1. See, we obtain that equation. Okay? Right. So now, actually that is not a part of the video. That is just to teach you how to remember the equation. Right? Okay. T2 divided by T1 equals V1 divided by V2 to the power gamma minus 1. Always the suffixes are getting interchanged. Right? So what is T2? Equals T1 times V1 divided by V2 to the power gamma minus 1. Gamma is 1.4. 1.4 minus 1 is how much? 0.4. What is T1? T1 is 27 degrees Celsius. That means we have to get the values in kelvins. So at 2732 that, so that means 300 kelvins. Right? Okay. So it is 300 kelvin. So this is 300. V1 divided by V2, that is the compression ratio. You know that. What is the compression ratio? Is that 18, right? Compression ratio is 18. Right. So 18 to the power gamma minus 1. 1.4 minus 1 is 0.4. Okay. So let's quickly find this. 18 to the power 0.4 multiplied by 300. 953.30. 953.30, but value is in kelvins. Check it. Yes. So T2 temperature, now you know, 953.30 in kelvins. Okay, right? Yeah, no problem. Right, so that is also done. Now we need to find T3, T4 and P4. Right. Okay, let's see how to do that. So now again look at the problem. In this problem they have told us heat added per cycle is 2000 kilojoules per kilogram. Okay, heat added per cycle, how much is it? 2000 kilojoules per kilogram of heat is added to the cycle. So now in that case you must know what is the process we add heat, because you are not going to add heat at every process. There is only one particular process where you add heat, right? So only heat addition process is this one, the red colored dot. Throughout this process 2 to 3 only you are going to add heat, right? I will put some red arrows like that. So from the point 2 to 3 only you are going to add heat at constant pressure. At constant pressure. Okay. So what is the equation you can use? Q equals mc theta. Q equals mc theta means delta theta, right? Temperature difference, right? And in this problem you are going to consider only 1 kilogram of air, right? Because if you are going to consider the working fluid, you are going to consider 1 kilogram of air, right? So that means M is 1. M is 1 kilogram. So M is 1. That means Q will come in joules. Okay, that's correct. But if you are going to consider for 1 kilogram, that means joules per kilogram, right? No problem, right? Joules per kilogram. Okay. But what is the unit that they have told us? It's not joules per kilogram, kilojoules per kilogram. Okay. Hold on. How to get that relationship? Because these are basics. So you have to be very sure about your basics. If it is Q equals mc theta, Q will come in joules, M will come in kilograms, C will come in joules per kilograms per Kelvin or degree Celsius, no problem. Temperature difference should come in. If it is Kelvin temperature, then Kelvin temperature difference. If it is Celsius temperature difference. Anyhow, the difference will also come in the same unit. Let's say Kelvin. So that means here the units of the C value is joules per kilograms per Kelvin. So the temperature difference will come in Kelvin. So Kelvin to Kelvin will cancel, right? If you are going to put this kilogram to other side, it will be joules per kilogram. So what is the unit of this guy, this C constant? Joules per kilograms per Kelvin. So that is how it comes. But carefully look at the problem, guys. What is the unit that they have given us? And also tell me what is the CP constant you have to use. You have to use Cp, because that is heat addition at constant pressure. So you have to use Cp. Simple. And that Cp constant in your exam paper, that is given in Cp 1.005 kilojoules per kilograms per Kelvin. Right? Kilojoules per kilogram per Kelvin. So that means the energy content will come in kilojoules per kilograms per Kelvin. Right? So I solved the doubt with the unit. Right? Okay. Now they have given you what is the energy added. What is the energy added? 2000 kilojoules per kilograms per Kelvin. What is M? That is 1 kilogram now. What is the constant you have to consider? Cp, because it is constant pressure heating process, right? So what is Cp? 1.005 kilojoules per kilograms per Kelvin. What is the temperature difference? You are going to add some heat, so that means definitely T3 will be higher. It must be, right? T3 must be higher than T2 because you are going to add some heat. So T3 minus T2, isn't it? Yes. So how to solve this? T3 equals 2000 divided by 1.005 plus T2, right? Okay, because you know what is T2. Okay. So quickly find that. 2000 divided by 1.005 will be lesser than 2000. 2000 divided by 1.005 plus 953.30. 2943, very high temperature. 2943.35 kelvins. 294335. Yes. So what is the temperature T3? 294335. 294335. Yes. So now you know what is T3. 2943.35 kelvins. So that is also solved, right? Clear? Because you cannot remember the things and do, especially when dealing with thermodynamics. You have to be very sure about the theories. Let's consider the process 3 to 4. Okay? Process 3 to 4. Right. Now, what are the things you know at the moment? Those are the things that you know at the moment. Okay? Right. Okay. We need to find P4 and T4. Right. So let's write the equations. What are the, how many equations that we know so far? P1 V1 to the power gamma equals P2 V2 to the power gamma, but now don't use the terms, the suffixes 1, because now the adiabatic process that we have here, now see, from this 3 to 4 you have adiabatic process, right? Adiabatic means not just adiabatic, reversible adiabatic. Adiabatic is different, reversible adiabatic is a special feature. So anyhow it is adiabatic. So process 3 to 4 is reversible adiabatic expansion, reversible adiabatic expansion. That means no problem, we can use the adiabatic equations for that, right? So what are the equations that we can use? We can use, this is one point, this is another, this is one starting point, this is another ending point. We can use P3 V3 to the power gamma equals P4 V4 to the power gamma. One relationship. And also we can use T4 divided by T3 equals P4 divided by P3 to the power gamma minus 1 over gamma. And we can also use, because now we already are familiar with these relationships, we can use T4 divided by T3 equals V, what? The reverse, V3 divided by V4, the reverse, V3 divided by V4 to the power gamma minus 1. Okay? Right. So what can we use? So let's go one by one. Okay. We know process 3 to 4 is a reversible diabatic expansion, right? Reversible diabatic expansion, or in other words, it is an isentropic expansion, right? Isentropic expansion. So now the last thing that we have to evaluate is T4 and P4, because we know all the other temperature and pressure values, because in this problem they are asking only temperature and pressure values, right? They are not asking about volume. Now this is the point that you should argue with yourself. You have to argue with yourself. Now basically, what are the three equations that we know? If I'm going to apply a diabatic relationship for this process, because we know there is a process called PV to the power gamma equals constant. This relationship we are using for diabatic processes. So now you can use that equation for this process. from 3 to 4. What is that? You can say P3 V3 to the power gamma equals P4 V4 to the power gamma. It's no problem. Okay. Or else you can use T4 over T3 equals P4 over P3 to the power gamma minus 1 over gamma. Also you can use T4 over T3 equals V3 over V4. T4 divided by T3 equals V3 divided by V4 to the power gamma minus 1. So basically we have three relationships and you know that. Now let me analyze what are the values you know. You know T3, no problem. You know P3, no problem. And T4, P4 are the values that you have to find. You don't know that. So let's analyze each and every of these equations to just verify the possibility whether we can use these equations or not, because these are the actual situations where the student is getting stuck, right? Can we use this equation? Definitely can't, because the reason P3 is okay but you don't know V3, so definitely you cannot find these values, so you cannot use this equation, right? That is a very simple logic. You know P3 but V3 also you don't know, P4 V4 definitely you don't know, so no chance. And let's consider this equation. Let's check whether you can find T4. You can use this equation to find T4, but you need to know all the other values, right? You must know what are the other values. T3 you know, no problem. P3 you know, no problem, but you don't know P4. So you cannot have two unknown things. So you cannot use this equation also. That's very logical, right? So now let's go to this equation. You don't know what is V3. You don't know what is V4. And T3 you know, so only by knowing T3 will not help you to find T4. So pointless. So you cannot use these equations directly. So to that, because like these are the things, just because you know the adiabatic relationships, you cannot find the value. So for that, you have to use some logical approach, right? Okay, so let's see how to do that. Several ways are there. I will teach you all the steps, right? Many methods are there. So now you know P3 to P4 is an adiabatic process. So no problem, you can use adiabatic relationships, but when we were analyzing all those three previous equations that I wrote, you know there were lots of missing values, right? Ultimately where we cannot find the required variable. So for that we can use something. Okay, so let me tell you. Now in this problem they have given us the ratio of V1 and V2, right? That means the initial volume V1 is reduced up to this level, right? Reduced up to that level. So you know V1 divided by V2 equals 80. This you know. So now you know, I will just say that again. So now this is a constant pressure heating process, so you can use ideal gas equation for that, right? So what is the ideal gas equation? PV divided by T equals constant. Okay, so you can use that relationship for this constant pressure heating process from 2 to 3. Okay, so no problem. So you can say like P2 V2 over T2 equals P3 V3 over T3. so no problem, right? And also you can say that the relationship for the compression ratio, you can use that also. So what is that? Initial volume V1 is compressed to a volume of V2, so V1 divided by V2 equals 18, the compression ratio. So you can use that relationship also. And so now we previously analyzed all other three equations for the adiabatic relationship from 3 to 4, but you could not use that because certain values you don't know, so because of that you can find. So let's say that you are going to use this equation, T4 divided by T3 equals V3 divided by V4 to the power gamma minus 1. Let's say that you are going to use this equation, okay? But unfortunately you cannot find T4 because the reason you don't know V3 and also you don't know V4. But let me just analyze like this. Now this is constant volume heat rejection. Like process 4 to 1 is a constant volume heat rejection process, 4 to 1. So that means this volume V4 equals V1. Agree? Right. This volume V4 equals V1 because constant volume heat rejection process. And also this relationship we can use for this constant pressure heating process. But this is a constant pressure heating process, you can cancel this P2 with this P3, right? Because pressures are same. So you can rewrite this equation like V2 divided by T2 divided by T2 equals V3 divided by T3. You can write like that, okay? And also V1 divided by V2 equals 18. So this means you can write V2 in terms of V1. So that means, how to say that? That means, so V2 equals the reciprocal of that, right? It's not the reciprocal, it's like V1 divided by 18. You can say like that. V1 divided by V2 is 18. So V1 divided by 18 is V2. So now you can put this V2 value that is there in terms of this up to there. Because how to say that, now we are trying to obtain a relationship by relating the volume, okay? There are lots of ways to solve that, but I'm going to teach you all the steps. But let's see this method, because if you know many methods it will be easy for you to handle in the exam, right? So this V2 you can write as V1 divided by 18. Agree? Okay. V1 divided by 18, right? Okay, so V1 divided by 18 divided by T2 you can write, and that is better if you write in the simplest form, V1 divided by 18 divided by T2. That you can write as V1 divided by 18 T2. Agree? You can write V3 in terms of the relationship that you are getting from here, okay? Right? So that means V3 equals V1 multiplied by T3 divided by 18 T2, right? Okay, is it clear? You can subject V3, V1 multiplied by T3 divided by 18 T2. And what is V4? V4 you know that is same as V1. Okay, so no problem. V3 divided by V4, let's put in V1 terms, because actually there my logic was, if V3 you are going to write in terms of V1 and V4 you are going to write in terms of V1, then you can cancel V1 to V1, right? So that would be a kind of an easy method, right? So now here you have V3. Replace this V3 by putting this value, V1 T3 18 T2. V3 is there. I will just I will write the same thing, V3 V4. V3 divided by V4 to the power gamma minus 1. Okay. What is V3? You can put this value, V1 T3 divided by 18 T2. Okay, right. What is V4? Here it was V4, right? So what is V4? That is same as V1, same volume. V4 same as V1, so put V1. Now V1 to V1 you can cancel, no problem. So what would be the answer? If I write here, will you be able to see? T4 divided by T3 equals this to the power gamma minus 1 term is there, no doubt. Here you have T3, here you have 18 T2, so that divided by 18 T2, because there you have 1. Now what can you say? T2 you know, you have calculated. T3 you know, you have calculated. T3 you know, you have calculated, so you can very easily find T4. That is one way of doing that. There are several ways, but don't worry, I am going to analyze everything. Right? So now I will again erase this part. Right? You can again revise the video. Like you can again go back of the video and you can see. Right? Okay. T4 divided by T3 equals T3 divided by 18 T2 to the power gamma minus 1. Okay. T4 divided by T3 equals T3 divided by 18 T2 to the power gamma minus 1. Because I want to save some space. Right? So these things also I am going to erase because I need space. Right. Right. Now here you have T3. Okay. So now you can subject T4. T4 equals T3 times T3 divided by 18 T2 to the power gamma minus 1. No problem. What do you have here? T3 to the power 1. Right? So no problem, right? T3 to the power 1. What do you have here? T3 to the power gamma minus 1. What do you have there? 18 T2 to the power gamma minus 1. Because if you are going to apply this power separately, right? 1 gamma minus 1. What can you do? You can add the power, right? So what could be the final answer? 1 plus gamma minus 1, that would be T3 to the power gamma. Downstep what? 18T2 to the power gamma minus 1. Okay, I hope you got it. So what is T4? The final relationship, what is T4 equals? T3 to the power gamma divided by 18T2 to the power gamma minus 1. Now no problem, right? Now no problem, right? Now it's no problem. You know T3, what is T3? 2943.35. 2943.35 to the power gamma, what is gamma? 1.4. 18T2 means 18 multiplied by what is T2? 953.30 to the power gamma minus 1. Gamma is 1.4. 1.4 minus 1 is 0.4. Okay. Let's quickly find that value. 2943.35 to the power 1.4 multiplied by to the power 0.4, 18 multiplied by 953.30. What is the answer? What is the answer for T4? 1454.04. Let's check whether is that the answer you are getting? 1454.04. Yes, 1454.04. Value in Kelvin. So now you know what is T4. Actually, now there was a kind of a mathematical part, but that is not magic. Okay, it's very easy. Okay, so now finding the pressure value P4. Now I don't think it's a difficult task. You can use any equation, right? So now how to find P4? Again, we have to go for this adiabatic relationship. So now you know T3, and also you know P3, and also you know T4. So that means there is no any sort of doubt, you can easily find P4. So how to find? You can use this relationship. T4 divided by T3 equals P4 divided by P3 to the power gamma minus 1 over gamma. Right? So now you have to find what is P4. So how to find that? So you can do something like that. You can get how to say that? You can, now the thing is you need to avoid this power gamma minus 1 over gamma. You need to just avoid that power. So what is the solution that you can do in order to avoid that? You can get the reciprocal power of this from both the sides. Okay, for example, that what I want to tell you is that if you have something called T equals P to the power K, right, you can get the reciprocal power of that. That means this to the power 1 over K and this to the power 1 over K. So if you say like that, if you get like that, this P to the power K times 1 over K, this K to this K will get cancelled, so this P would be remaining. So something like that. So you can get the reciprocal power from both the sides. That's a simple trick, right? So T4 divided by T3, the reciprocal power, that means 1 over that power, means 1 divided by gamma minus 1 over gamma means gamma over gamma minus 1 equals. So what will come if you get the reciprocal of this one? P4 divided by P3 to the power gamma minus 1 over gamma multiplied by gamma divided by gamma minus 1. This will get cancelled, this will get cancelled, so you would be getting P4 divided by P3. Okay, no problem. So no problem, you will be getting that P4 divided by P3. So you can put this P3 to that side. You can find P4, right? I think well done. So now what is the value? I will again write the equation. P4 equals P3 times T4 divided by T3 to the power gamma over gamma minus 1. What is P4? You don't know. What is P3? P3 is a constant pressure process. You know what is P3? That is how many megapascals? 5.72 megapascals. Okay, no problem. 5.72 megapascals. What is T4? 1454.04 divided by what is T3? 2943.35 2943.35 1454.04 to the power gamma over gamma minus 1 means 1.4 divided by gamma minus gamma minus 1 is 0.4. Is it? So what is the answer? Quickly, let's get the answer. 1454.04 divided by 2943.35 to the power 1.4 divided by 0.4 and that multiplied by 5.72. What is the answer? 0.48 megapascals. 0.48 megapascals. Let's verify the value. 0.48 megapascals. Yes, that is the value. 5.72, 1554.04, 2943.35, 1.4 divided by 0.4, 0.48 megapascals. So that is the pressure. 0.48 because I am getting the answer up to 2 decimals. Yes, so it is done, right? So that's the part, right? Earlier we used the substitution method where we made some relationship by substituting V1, right? I think you can rewind the video and see that. Now let's see what are the other methods that where we can find T4 and P4. Okay, let me teach you that. Now we know our inlet conditions. What are our inlet conditions? P1, the pressure at there 0.1 megapascals and temperature T1 27 degrees Celsius. And because here we have constant volume heat rejection. So this volume, now see, if you are going to consider this volume axis, it is at the same level. Okay. So V4 equals V1, right? Right. So we know we can use this ideal gas equation. PV equals MRT. So what is the mass that we are going to consider here? 1 kilogram of air. M equals 1 kilogram. Right? Okay. So pressure 0.1 megapascal, that means 0.1 into 10 to the power 6 pascals. Standard units we can keep. Volume you don't know. Let's say volume V1 in cubic meters. Right? No problem. What is M? Equals I will put in the next line because I don't have enough space. 1 kilogram. This multiplied by that equals the other part of the equation I will put here 1 kilogram 1 kg times R. What is R? 287. the universal gas constant 287 joules per kilograms per Kelvin. T temperature, what is the temperature here? 287 plus 300, not 300 plus 273. You have to convert that into Kelvin, so it is 300 kelvins. 300 kelvins. Okay. So let's find what is the volume V1 in meter cube, because we can verify whether our values are correct or not. What is the volume V1? 1 multiplied by 287 multiplied by 300 divided by 10 to the power 6 divided by 0.1. What is the volume? 0.861. 0.861 meter cube. That means 0.861 meter cube is the volume at here. Okay, so the volume at here is same as volume at here. So you know what is V4. Okay, you know what is V4. And if you know, because like if you know V1, then you know what is V4. And also if you know V1, you also know what is V2, because the reason V2 is 1/18th of that, because the compression ratio. V2 is V1 divided by 18. So you know V2 also. Right? You know that also. Okay, so let's write that here. What is the V1 that we have calculated? 0.861 meter cube. Right. So let's erase that. Right. So now that means now we are going to find this T4 and P4 in a different method, right? Okay. And so now how to verify that? V4 is known. T4 we do not know. Let's say like that. T3 we know, because T3 we have previously evaluated, right? And if we know what is V3, then we are done, right? So how can we find V3? Okay, so again we can use ideal gas equation. You know that. So you can use that ideal gas relationship to the process in between 2 and 3. P2 V2 over T2 divided by T3 V3 over T3. Constant pressure process, so you can cancel P2 and P2, right? So I will write it again. You can cancel P2 and P3 because P2 is same as P3. So V2 over T2 equals V3 over T3. Right? What is V2? V1 divided by 18. T2, V3 over T3. Now, what is V3? You can subject V3. Okay, you can subject that. So what is V3? V3 equals V1 divided by 18 multiplied by T3 divided by T2. So you can subject that to here. In order to save space, I will write that on top. Okay. So V3 equals, look at here, V3 equals V1 divided by 18 multiplied by T3 divided by T2. Okay. Same thing. Okay. So now tell me what is that V1, you know, 0.861, T3 you know 2943.35 kelvins, and this is 18. What is T2? 953.30. Quickly tell me. 0.861 multiplied by 2943.30. 35 divided by 18 divided by 953.30, 0.148 meter cube. 0.148 meter cube. That means now you know V3 also, right? 0.148. Okay guys, so I will erase this. If you want to look at the working again, you can rewind and see. Okay, right. And so now no problem. You can find what is T4. What is the equation that we have now? T4. Write again. Okay. I will write this again. What is the equation now? T4 divided by T3 equals, if you are going to consider volume, that is the reciprocal, the interchange order. It should be T4 divided by T3, it should be V3 divided by V4. T4 divided by T3 equals V3 divided by V4 to the power gamma minus 1. Okay? Right. So no problem. What is T4? T3 times what is T3? 2943.35. 2943.35 times what is V3? We calculated. Where is V3? Oh my god, did I erase that? Okay, 0.148, right? V3 is 0.148 meter cube. So 0.148 divided by what is V4? That is same as V1. What is our V1? 0.861. 0.861 to the power gamma minus 1. Gamma minus 1 means gamma is 1.4. 1.4 minus 1, 0.4. What is T4? Let's see whether our values are matching. 0.148 divided by 0.148 divided by 0.861. 0.148 by 0.861 to the power 0.4 multiplied by 2943.35. Yeah, it is 1455.28 Kelvin. 1455.28 Kelvin. So a little variation is there, right? So based upon the value that we evaluated from the previous step, what is the value if we obtain it by this? It is 1455.28. That means there is an error of 1.24 error. Okay, it doesn't matter, it's very closer, right? It's very closer, right? So you can find T4 like that. So now the last part, what is the cycle efficiency? Cycle efficiency is neta. What is cycle efficiency neta? That is net work done divided by heat input. So now net work done divided by heat input. So if you are going to consider this heat input, that is the heat input to the cycle, right? So there we are not going to worry about the actual heat energy given by the fuel, because if you want to consider the actual heat energy given by the fuel, then they should give us related information about the source of fuel. Cycle efficiency means the net work done divided by the heat input. So what is the heat input actually? Because in this problem there is only one process where we give heat, so that is the heat input. So in the question it clearly says the heat input. See, in the question they say heat added per cycle is 2000 kilojoules per kilogram. So that is the only heat added. So you know heat input 2000 kilojoules per kilogram. So you need to find this part. What is net work done? So net work done is net work done is actually we give heat in order for this cycle to do some work, right? So, and there is certain amount of heat that it releases. Now for an example, I am giving you 1000 rupees for you to eat and you are giving me balance after that. So that means what is the cost for the food? The amount that I have given to you and the balance that you have written. So now here you can see there is a heat rejection process. See this one, there is a heat rejection process. So this is the heat that I give to the cycle and this is the heat that is rejected from the cycle. So heat given minus the heat rejected is the net work done. Okay, so net work done is, because you know the amount of heat that is given, right? You know what is the amount of heat given, so that is 2000 minus what is the heat rejected. So heat is rejected from the process 4 to 1. See, heat is rejected from the process 4 to 1 here. See, 4 to 1, right? So heat is rejected at the constant volume. See, very clearly see, process 4 to 1. This is a constant volume process. So what is the heat rejected? Let's say HR, heat rejected. It is done at constant volume. So we have to consider CV, right? CV. What is the equation? Q equals mc delta theta. But m, you don't need to worry about m because we are going to consider 1 kilogram of air. So m is 1, right? So that is why we get the amount in kilojoules or joules or whatever, let's say joules per kilogram, because you are going to consider 1 kilogram of the food. But because the CV constant that we are going to consider is 0.718 kilojoules per kilogram, definitely without any worries you can put the unit is kilojoules per kilogram. What is CV? 0.718. 0.718. What is the heat rejected? T4 minus T1. Because like definitely if you are going to consider the level at 4, the temperature at the level 4 must be higher than that because it is going to release some heat. So if it is going to release some heat, the temperature at this position 4 must be higher than position 1. You know what is T4 and T. What is T4? 1454.04 minus what is T1? You know that is 300. Quickly tell me what is the value for that? 1454.04 minus 300 multiplied by 0.718, 828.6. 828.6. That means the heat rejected is 828.6. Right. No problem. Right. Okay. So now you can find what is the cycle efficiency. 2000 minus 828.6, how much? 1171.4 divided by 2000 kilojoules per kilogram. 2000. So it is 0.5857. 0.5857. 0.5857 means it is 58.57 as a percentage. Okay. So let's check whether that is the value that you have obtained. 58.57. Okay. Right. Must be a value closer to that. Right. So the cycle efficiency is also calculated. Right. So now I think the entire problem is clear to you. Right. So I think we had a great effort. Thank you so much for being with me during this problem solving session of diesel cycle. Right. So that's it. Okay. So I will give you a very little summary about the cycle. Now I will erase everything. We discussed 2014 final question paper that is related with diesel cycle. Right. So now all values are evaluated, right? So okay, with me tell me PV diagram, diesel cycle, reversible, adiabatic, or in other words isentropic compression. 1 to 2 you are going to compress. How? Adiabatically, but reversible. 2 to 3 at constant pressure you add in some heat. Okay. Then you are going to expand volume, you are going to enlarge the volume, but that is also reversible adiabatically. And then constant volume heat rejection. 3, 4. 1, 2, 2, 3, 3, 4. Right? So now you know what is 1 to 2, what is 2 to 3, what is 3 to 4, what is 4 to 1, how to deal with the relationships without memorizing, and how to find the cycle efficiency. Right? Right, okay. So you can comment me, you can contact me through the mail. If there is any sort of problem with the calculations, you can just let me know. Okay, thank you so much and all the very best for your thermodynamics examination. Okay, thank you.